Welcome to our today's class. I remain Victor Odigoma here, your mathematics tutor. Okay. We've been able to do a lot of work in linear and quadratic graph, and I deemed it necessary for us to introduce a new topic. Okay, we've not exhausted what we are doing over there, but we have to introduce a new topic so that maybe people that have interest in this area as well can also follow us there. Okay, if you are uh, visiting us for the very first time, I will adjourn you to subscribe to this channel because this topic we are looking at now is a sequence and a series, and it's going to take within 12 to 13 classes or more than, depending on the requirement, the demand. Okay, so if you don't subscribe, you will not know if you don't subscribe, you will not know you will not be able to follow what we are doing. But when you subscribe, you realize that you'll be able to be subscribe and then click on the notification button as well. They are just there. Okay, it doesn't take time, so that you'll be notified. The classes will be, the progression will be going. Okay, and then you'll be able to follow whatever we are doing here. Okay, so today we are looking at sequence and series. Sequence and series. What is a sequence? What is a sequence? We know that if I am to explain this to a layman, I will say that sequence is an arrangement of terms, occurrences, events, an arrangement of terms in such a way that they follow a well-defined pattern. Terms that follow a well-defined pattern. Let me give you an instance. If you have, take for instance, at the end of this lesson, if you look at these questions that are here, that's questions like this and questions that are big, stronger than this is what you should be able to handle if you follow this class. Because my target is to bring you to the point where you can be able to handle problems like this and stronger ones like this. So I'll start from the scratch. After this explanation, I'll do one and then take you to the next class which we have. Okay, so we are talking about sequence here. Example, if you have something like 2 and the next occurrence is 5. If you watch here, okay, these two terms, maybe there's the gap of 3 between them. If I add 3 to here, I will get 8. If I add 3 here, I will get 11. Yeah, 8 plus 3 will give me 11. Yeah, then if I add 3 again here, I will get 14. What about if this is a continuation? It's a progression, it continues to go like that. So we can call this a sequence. What about B? What about if I have something like 3 here, and the next you observe is 9, and the next you observe again is 27, and the next you observe again is 81, and the thing continues in that order. If you check out on this and this, you realize that they are not the same in pattern. They're not the same. So if you look at this, you realize that this is going by addition. You realize that when you add 3 here, you get this. Add 3 again, you get this. It is by addition. Okay, and then but here, if you add 3 here, if you add, okay, what am I going to add to this to get this? It is 6. If I add 6 to this 3, I'll get 9. But add that 6 again, you realize you can't get 27. So you see the process where this by which this is going is different. If you observe closely, you realize that this is going by addition of a particular value to get the next term, and this is going by product of a particular value with what is current to get the next. So if I multiply 3 by 3, I'll get 9. 9 times 3, 27. 27 times 3 will give you 81. Okay, it continues like that. Now, they have, the descriptions that we are going to study. in the course of this class. This is called an arithmetic progression, and this is called a geometric progression. So we are going to look at them differently. Okay, in the subsequent class we are going to be looking at. Both are increasing. They are increasing. Now, what about if I have 15 and I remove 3 and I get 12? Remove 3 again, 9. Remove 3 again, 6. And it continues like that. This is by addition of minus 3 to each term. You get the next, and it is a decreasing sequence. What about if I have 1 over 2? Multiply it by half, 1 over 4. By half again, 1 over 8. By half again, 1 over 16. Can you see that this is a decreasing sequence and it is geometric? The decrease is geometric. So these are instances or what I can use to explain or buttress what I'm talking about in sequence. The sequence can be arithmetic, can be geometric. So that is a simple explanation. There are so many things we are going to be talking about here, like what is the first term and how can one be able to look into the future and do a prediction. Okay, so if you, without wasting our time, is then in application there are some problems that can come up like this. You see that first one there, 16 over 9 comma x comma 1 comma y, and then the question say they were very good enough to tell you it's a GP. You could have discovered that by yourself by doing some arithmetic, calculation there. So say find the product of x and y. How can one be able to do that? And in this other one, it says the second, the third, and the fourth terms of an IP are x minus 2, comma 5, and x plus 2. They find x. So how can one be able to handle a problem like that? Now, from the previous explanation I gave you on this, you realize that if you have from that A now, you realize that if you have 2 and then you have 5 and then you have 8 and then it continues, you realize that the value that the difference here gave you is the same thing here. Did you realize that 5 minus 2 is 3? And the same thing is applicable to 8 minus 5. It is still 3. So if you are careful enough to discover this, this both is called the common difference. So that difference is common. It's existing across the terms. It's common. So we call it a common difference. So this concept now will help you to enter this. So if I am to solve this now, I will handle this and then this will be in our next class. What I'm doing here now is just to introduce you to this. I'm going to, in the next class, take you to arithmetic progression. We go deep down inside arithmetic progression, and then before we now venture into geometric progression. I told you to make sure you subscribe to the channel so that you can be able to follow the classes. I told you that I will give you the best by the grace of God. Okay, so this question that I want to handle, says the second, that is, if I am to answer this question, say solution T2, T3, T4. So you know that the common difference, since we have been told that it's an arithmetic progression, meaning if you add a particular common difference, as I explained here, you will get the next. So it then means that that common difference, as I did here, will be T3 minus T2, or that common difference will be, I'm sure I'm not going away from, let me clean here and do it here so that you can get what I'm saying. So it's either that common difference D is equals to T3 minus T2, or it will be T4 minus T3. So it then means in this case now, in this case, the second is so the second is x minus 2. So it then means here D is equals to 5 minus, let me write that in very well so that you can get it. X minus 2, this is T2, comma 5, this is T3, comma, then x plus 2, this is T4. So I can choose to say that my common difference D is equals to T3 minus T2. That's to say 5 minus bracket, this is it's regarded as a one single term, so I have to put it in a bracket because of the way it is, x minus 2. Okay, and that same common difference again is T4 minus T3 can be that, and it's still the same thing. So it is going to be x plus 2 then minus 5. If you watch these two, I'm sure this is taken. Let me clean this place, because my concern is for you to see what I'm doing here, not just to do a demonstration and go. So do you realize that D being equals to 5, the first one, the first line, let me call this equation 1 and then equation 2. The first line, do you realize that D being equals to 5 minus x plus, because if this enters here, it becomes plus 2. Okay, and this is also D being equals to x plus 2 minus 5. So I can say, since D is common, I have made this type of explanation some time ago. Since D is common, I can equate this and this. Let me repeat this equation 1 and repeat this equation 2. Since D is common in both, I can say 5 minus x plus 2 is equal to x plus 2. Of course, here will become what? What is it going to be? 2 minus 5 will give us minus 3. Okay, minus 3. So what do we have? If we collect the like terms, we are going to have this and this. 5 plus 2 give us 7. Okay, this minus 3 will come over here and become plus 3 equals to, this is x. Okay, this will become plus x. So we have 10 equals to 2x. So it then means if I divide both sides by 2, if I divide both sides by 2, I'm going to have over 2 here, over 2 here, and then the implication is that x is equals to 5. Realize that the sequence we are now talking about, x minus 2, which is the second, that is, this is T1, T2, T3, T4. Let me stop there. The second is x minus 2, and our x is 5. So 5 minus 2 will give us 3 here, followed by T3 is given, it is 5. It's 5. Then T4 is x plus 2, meaning 5 plus 2, which will give us 7. Look at the sequence. Okay. Can one possibly find what is the first term? Can also be a question. Okay, I don't want to stretch this class too much anyway. One can possibly do that. Okay, then it's just a matter of saying the first term will now be okay. There is an expression I need to use to get that, which is which is Tn is equals to A plus in bracket n minus 1 D. This expression, I'm going to introduce it to you in the next class. Thank you so much for watching. Okay. I remain Victor Odigoma Ohia. I encourage you to subscribe to this channel so that you can follow everything we are doing here. Okay. Share it to your friends, like our videos, and then click on the notification button so that you can be able to follow whatever we are doing. God bless you.